fundamentally, when we think about sometimes the term resiliency or high availability, and sometimes even those two terms can be used interchangeably depending upon who you're talking to. But essentially, what we're saying is, in case something breaks, you want to have a backup. That's as simple as I can put it. And so,
Right.
what you also see here in this VPC is that it's across two different availability zones. You see AZ1 at the top, then you see availability zone 2 at the bottom. And so, the idea again is that if one area, right, let's say traditionally you're accustomed to a data center, like a physical building. If that building goes down, right, if there's a fire or earthquake or electricity power is down, something, meaning the service is not available to you, you want to have a backup, right? A backup way of being able to ensure that your application is still running. The beautiful thing that I absolutely love about being in the cloud is you never have to physically leave anywhere, right? I can do all of this maintenance and management and, outside of pushing the off and on button, the power button to the
Yes.
server, right? That's about the physical touch that we need. But at the end of the day, it's about ensuring that if your application server or the application breaks or it's not available in one space, one AZ, it's still available across another AZ. And Ariel will talk about the whole point of this kind of auto scaling group and the little dotted orange blocks that you see around those two app servers here.
Absolutely, coach. And so we have these applications in different AZs. To kind of brush up on that, we spoke about that on week one. I think that was the first day when we considered the global infrastructure. And when I consider this auto scaling group, this element that Coach Charisma is pointing to, considering these app servers, you can kind of see the app servers in this rectangle, this dotted orange rectangle. And what we're indicating here is that we're going to automatically deploy our compute units. In my on-prem days and physical days, if I needed to have an additional compute unit out there for more availability of the application, I had to build it out. I had to build out those parts and connect it to the network. Well, if you come here with AWS and you're going into the AWS Cloud Practitioner certification, you need to understand that you can automatically deploy virtual devices. So the first time that I go into the system, I can create all of the configurations that I need for a compute unit like this app server. And I can be specific about the OS, I want the storage, and what type of network connections that I like. And after I get that perfect, I'll say, you know what? I'll plug that into what's called a launch template. And that will be assigned to this auto scaling group mechanism. And the reason why this orange rectangle is bleeding into both areas of this VPC is because we've chosen different areas within what we call the region. Again, go back to first day, week one, to kind of learn about the global infrastructure of things. But now I have an opportunity to deploy into these separate areas within the region, as Coach was telling you about. I got more availability now. That data center that's in availability zone 1 that goes down, that's fine. I'll send my customers or the connections or the end users to public subnet 2 that's in AZ2. So we got some highly available architecture here.
And we'll go a step further, right? Where we think about what is that application load balancer that we see even before that. Right? And the beauty about that is think about this like you're going to a restaurant and you've got someone who greets you at the door, and it's going to place you or seat you somewhere depending upon their load, right? How busy is the kitchen? Who's working, right? What's the resources that we have behind the scenes? And so what that application load balancer in this diagram shows us is basically alluding to the fact that it's going to route the traffic, right? It's going to route the traffic to either the app server that we see in availability zone 1 or the app server that we see in availability zone 2. And we can route that traffic depending upon what our needs are or the requirements of the application, criticality. Sometimes we call that, maybe it's an SLA that's associated to it, or maybe it's just the criticality of the systems or what the application needs to be maintained. Sometimes it has to be up a certain period of time, right? From a banking perspective, I want my checking account information to be up all the time, right? If I think about it that way, right?
Yeah.
But if I'm looking or researching something in the library, it may not be as critical of a need to keep that application up and running or accessible within a certain SLA. So that's kind of what that lends into as well.
Absolutely. Yes. And now I have an opportunity to say, and just related it back to what we said previously, Coach, one thing goes down, the mechanism that's getting that traffic to funnel into AZ2. Let's say if AZ1 goes down, is that application load balancer. So excellent explanation of that, Coach. You got stuff to study for, folks. Not only do you want your compute units to be on either side of the region, right? But the data, right, for those applications, how are you going to store that data? Maybe you're storing it in the database layer. And I know if I'm going for the cloud practitioner, the words that are on the screen now in the database layer that doesn't have this vertical box, connecting them to, but you see this dotted line that's connecting from Amazon Aurora primary DB instance to the Amazon Aurora replica. Now, if you're going again for that cloud practitioner, what you really need to understand is that this is a service within a service called RDS, the relational database service. And what's really highlighted out of that exam is there's two ways in which you could orchestrate some database layer. I remember when I was a system administrator, and I had the task of creating a database table because I just learned how to use SQL. And so it was pretty fun for me to say, hey, I created a database table. I went from doing that to creating databases, collections of tables, and I needed to use a structured query language to really communicate to the database. And just frankly, I'm organizing my data in a structured way so that I can use it for my app server. Maybe on the app server, there's an application that's pulling from this database. So I need a way to kind of structure that data in a real organized way. That's why I'm going to use the relational database service, and that's going to be on the exam. And understanding that Aurora is going to be a flavor of that database layer that takes away the management of being operational in the cloud with the database is something that is good to understand as well. Now, remember, when you're going through this exam, you just need to know definition of the term, right? You just need to know the terminology. And so that's what I'm really pointing at. There's other database options out there, and the exam will also highlight non-relational databases. So there's database layers that you can create, and really I should say tables that you can incorporate into your architecture that don't have to use a structured query language. The data doesn't have to be so structured. DynamoDB, and that's going to pop on the screen here. And you'll see that pop on the screen, but DynamoDB is also another way for you to kind of organize your data and utilize it for your, let's say, application server here, right? So you got this highly available architecture that allows you to send traffic to your compute units in one side of the region, but we want to duplicate that process in the second side of the region. And again, we don't just want to do that with our compute, but also our database layer.
Sounds good. Sounds good. And something that I think we can come back to here for a minute is coming back to the Autoscaling group, right? What if we've got our application load balancer that's handling the load, right? Balancing the load, directing the traffic either to availability zone 1 or 2. But then what happens if I need more compute resources? What if I need a bigger or just more servers to come on? Now, if I'm thinking about myself from a traditional kind of just hardware perspective, that means I've got to rack and stack and bring up a whole new physical separate device. Well, again, the beautiful thing about being in the cloud, when we think about the way that we're able to spin up these resources so quickly, is now I can create this template that Ariel mentioned before and tie that back to the Autoscaling group so that as I need more compute resources, depending upon the load that's coming in the front door, I can now spin up the exact replica of another app server in availability zone 1 or another app server in availability zone 2 and still be modeling the same exact specs, the same exact instance type, the same exact baseline, so that again, from a security perspective, it all makes sense, right? I'm not recreating something completely brand new, and I can do it in a matter of seconds. In some cases, maybe minutes, depending upon the size, but usually around seconds. And when you think about what that means from traditional speed, right? Having to spin something up physically, rack and stack and mount something, right? A tremendous difference of doing something like that in the cloud, meaning spinning up a new server in a matter of seconds and minutes.